Okay, this is the final section on trig equations, and I think this is the most difficult one. So try to pay attention as we talk about trig equations part 4. These are multiple and fractional angles. Here's my first example, and you're going to see immediately the issue with these problems, and that is instead of saying cosine x, it's going to say cosine 2x or cosine 3x or cosine 4x. So what you want to do is you want to kind of draw a box around this angle and just let it be the angle. So don't even think about the 2x. Just say, okay, what angle has a cosine of -1/2? Okay, now in your 9-part chart, if you think about it, I'm just going to draw a part of it here. Here's the cosine row, and here is the square root of 3/2, and here is the 1/2. This is pi over 6, pi over 3, pi over 4, and right there, the cosine is 1/2 for pi over 3 angles in, here's my thinking cloud, pi over 3 angles in quadrants 2 and 3. Those are the two places where cosine is negative. So I boxed the 2x and I just said, okay, so the cosine of the angle is -1/2. So the angle would be the pi over 3 angles in quadrants 2 and 3. So nothing's different, except right here I'm going to say 2x is equal to, and the pi over 3 in quadrant 2 is 2 pi over 3. And in quadrant 3 is 4 pi over 3. So far everything's exactly like what we usually do. Now, if this is a 2, you have to go around the circle 2 times. Okay, now if it had been 3x, we would have gone around 3 times. If it was 4x, we've gone around 4 times. So I have to do 2 more angles. And in other words, I want to go around again, and you can do it 2 ways. You can add 2 pi to it, or you can just double the bottom, which is 3, so you get 6, and add 6 to the top, which would be 8 pi over 3, and add 6, which would be 10 pi over 3. So this right here is the first time around, first rotation, if you will. And this right here is the second rotation. You're going to have as many rotations as you have the number. Okay, now again, the way you get here is you add 6 pi over 3. You add 2 pi. And the way you get here and here, you add 6 pi over 3. Okay, so there are 4 answers right now, and that's what 2x is. Now, I don't want to leave my equation 2x equals. I want to know what x equals, so I divide all my angles by 2, or basically multiply by 1/2, and I get 2 pi over 6, 4 pi over 6, 8 pi over 6, and 10 pi over 6. And all of those will reduce. That's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I'm not real strict about your reducing them, so if you don't, that's okay. X equals. Now, this is kind of a tough idea, so I'm going to go through this several times, and if we run out of time on our video, then we'll just have to figure the rest out in class. Let's look at example 2. Okay. Example 2, square root of 2 sine 2x is equal to -1. Now again, I'm going to box 2x. You do not break in on that. That's the angle. So I'm going to divide by the square root of 2, and I'm going to have the sine of 2x is equal to -1 over the square root of 2. Now, we don't want to leave that radical down in the bottom, so let's rewrite that. The sine of 2x is equal to negative square root of 2 over 2. Okay, remember, this is the angle. So the sine or the angle that has that sign, think, is pi over 4 angles in quadrants. Let's see, sine is positive in 1 and 2, so we need it in 3 and 4. This is the angle. Don't worry about it having a 2 in front of it. We'll take care of that in a minute. Okay, so 2x would be the pi over 4 in quadrant 3, which is 5 pi over 4, and in quadrant 4, which is 7 pi over 4. And this is the first time around. Now, because it says 2x, we have to go again. And that's pretty simple. Double the bottom, which would be 8. Add 8 pi to the top, which would be 13 pi over 4. And add 8 pi to the second one would be 15 pi over 4. And that's the second rotation. All right, once you do this, then you don't want to leave your answer 2x equals. You want to say, so x equals, and you're just going to divide everything by 2 or multiply by 1/2, which basically makes all the denominators 8. And we get 5 pi over 8, 7 pi over 8, 13 pi over 8, and 15 pi over 8. Excuse me. Sorry. Okay, and those are your final answers. All right, quickly, let's move to example 3. I'm trying to get in as many of these as I can. Here is sine of 3x equals -1. Okay, you cannot touch this. That's just the angle. So ask yourself, which angle has a sine of -1? Now remember, sine is -1 where, this is my thinking, sine is the y. So where is y -1? Well, that would be here at 0, -1. That's the only place. So 3x is equal to, the sine of this angle is -1. 3x is equal to, that is 3 pi over 2. Now, because it's 3, this says I have to go around 3 times. So the way to figure out what another time, so anyway, we go around to here, and then we go all the way around and come back, and then we go all the way around and come back. So the easiest way to do that, this is the first rotation. Then we double the bottom, we get 4, so we get 7 pi over 2. That's the second rotation. And then we double the bottom 4, and we go around and add 4 to the top and get 11 pi over 2. This is the third rotation. So there are the 3 answers, or the 3 rotations. Then x is equal to, we want to divide by 3, or multiply by 1/3, or just change the bottoms to 6's. 3 pi over 6, 7 pi over 6, and 11 pi over 6. And this one would reduce to pi over 2, which would be fine, but you don't have to worry about that. Now the way this works, of course, is you multiply this angle times 3. So this 3 pi over 6 actually becomes 9 pi over 6, which is 3 pi over 2. This becomes 21 pi over 6, which is actually 7 pi over 2, and this becomes 33 pi over 6, which is actually 11 pi over 2. So you can see that's how it works. Final answers will be what x is, not what 3x is. Moving on, so I can get a couple more angles in. My next 2 examples have to do with, here's the example, not multiples, but parts, fractions. Okay, I'm going to draw a box around theta over 2. Basically, we're saying the sine of this angle, again, this is the angle, theta over 2, the partial angle, fractional angle, is 1. So that angle is, sine is 1 where y is 1, which is right here. This is the point 0, 1. So theta over 2 is equal to, that is pi over 2. Now, if it is a fractional angle, like this, not a multiple, but a fractional, you do not have to go around more than once. In fact, you don't want to. You just want to let that be the only answer. And then, we don't want to answer theta over 2. We want to answer what is theta. Now, in the past, we divided, but in this time, we're just going to multiply times 2 here to make that theta, and times 2 here. And the final answer on this one is pi. And that's your only answer. Now, you will never have to go around multiple times if it's a fractional angle. You will always go around multiple times if it's a multiple angle. Note, it is possible it is possible, since you are multiplying and making this bigger, it is possible to get out of range. Now this one did not. Remember, we're going to answer between 0 and 2 pi. But if you do go over 2 pi, you need to throw the answer out. Let's see what happens on my last example. I've got about 5 minutes, so I think I can get one in. Okay, this is 2 radical 3 cosine x over 2 equals negative 3. Now I'm going to put a box around this because this is our focus here. All right, so cosine of x over 2 is equal to negative 3 divided by 2 radical 3. All right, now I need to simplify this, so let's multiply this by radical 3 over radical 3, which is going to give me negative 3 radical 3 over 2 times 3 is 6. And of course that goes there. And so basically this is my problem. The cosine of x over 2 is equal to negative square root of 3 over 2. Okay, let's box that. We know that the angle that has a cosine of this is pi over 6. The cosine of pi over 6 is equal to that. And cosine is negative in quadrants 2 and 3. So my x over 2 will be the pi over 6 in 2, which is 5 pi over 6, and in 3, which is 7 pi over 6. Now, I don't want, so those are my two answers. This is a multiple, so I don't have to go more than once. Now I need to double both sides, double both sets, because I need to make this an x, and I need to multiply those by 2. And what that's going to do is basically change the denominators to 3. So x is equal to 5 pi over 3 and 7 pi over 3. Now remember, our answers need to be between 0 and 2 pi. So 6 pi over 3 is 2 pi. So see what's happened? This angle is too big. So we will throw it out. And you will only have one answer. X is equal to 5 pi over 3 for your solution. Okay, I have a few minutes, so I'm going to go back over this. To me, this is the hardest of our types. We've saved the worst for last. Let's just look back over a couple of our examples here. Here was the first example. Remember I drew a box around this and I said let's just call that the angle. And so this says the cosine of the angle is negative 1/2, and we know that that value is pi over 3. I needed it in quadrants 2 and 3. So these are the two answers that you would normally think of. Because it has a 2 there, it says that we have to go around the circle 2 times. The easiest way to do that is to take the bottom and double it and add it to the numerators of both fractions. So I doubled that, got 6. 2 plus 6 was 8. 4 plus 6 was 10. This is the first rotation. This was the second rotation. And then we just divided everything by 2, which in this case is the same as multiplying by 1/2. And we got this set of answers. All right, look, the second example, same thing. This 2x says we have to go around 2 times. So what you have here, this is the first rotation. This is the second rotation. I got my answers based on what I already knew, and then I went back and divided by 2 or multiplied by 1/2, changed all the denominators to 8. All right, let's skip over and do one that's a partial angle. This is not 2 theta, this is theta over 2, 1/2 of a theta. Again, where is the sine 1? We got the angle, that's theta over 2, then we doubled both sides, and I warned you it was possible to go out of range on this, and so on the last example, when we did that, you see one of our angles was too large, so we throw it out, leaving us only one angle. This is the final section in this chapter, and we will have a test now on these 4 sections. Thanks for listening. We're done.